potential divider. Potential divider, the formula you know. Just we are having the review, how it is working. Can you write this heading, variable potential divider or potentiometer? That one was only potential divider. Now we are going for variable potential divider or potentiometer. Look, here we got fixed resistors. Both are fixed resistors. If they are both fixed resistors, that time we call it only potential divider. But if we have one of them variable resistor, then we can vary the voltage output. Across this R2, we can vary voltage output, and this type of potential divider is called potentiometer. Is it clear? So,
Yes, sir.
okay. So you draw this diagram. After writing this heading, you draw this diagram and then write this formula. Okay, now I'm giving you one example. Here we have, you have to do it. And my example, you have to do the working. For example, here in V the voltage is 8 volt. Okay, and for R1 the value is 2 ohms. And this one is 6 ohms. Okay, then you calculate V out. What is the value of V out? You calculate and tell me what is the answer.
Six.
6 volt. Okay. 6 volt. If you calculate, it comes 6 volt. Now you can change it. For example, here it is still 2 ohms. But we are getting here this resistor, it is changed. If we change it, then for example, it is no more now 6 ohms. We are making it different. I am erasing it. Have you finished this? Have you finished?
Yes.
If you are done, I'm not erasing even. I am writing another one. No problem. Then you can understand. We are doing 2 examples. So now it is, for example, 4 ohms. Then what will be your voltage output? If it is 4 ohms, then what will be your voltage output? You just give one comma, then you'll understand. These are 2 examples.
Sixteen by 3.
How much?
16 by 3.
Just loudly, please. I'm not getting.
16 by 3.
16 by the decimal point. You say it's a decimal point. What is the answer? 2 or 3 significant figures. Calculator. Oh,
5.3.
5.3. 5.3.
3 অনেকবার আসছে like
Okay,
5.3
5.3 volt. You can make it two significant figures. Then it is 5.3 volt. Azmain,
Yes, sir.
you are attending class. This is really nice. I appreciate it. You will be more appreciated if you are taking part in discussion. Okay. So you are
Okay,
also
sir.
doing working.
Yes, sir.
Okay, this is 5.3 volt. So we see uh, by changing the resistance, we can change the output voltage. If this one is getting now 5.3, then R1 getting how much? How much R1 is getting? Can you calculate? 8 minus
এবার
5.3.
R1 এর ভোল্টেজ করব
Hmm. No, not calculation. It's very simple. You just subtract. Your given voltage is
from the
8
total.
volt. Your given voltage is 8 volt. So if you subtract 8 minus 5.3, then you will get it. How much it is?
2.7.
2.7 now. Now it's 2.7 volt for R1. But previously it was 2 volt, isn't it? For R1, when V out for R2 was 6 volt, that time R1 was 2 volt, right?
Yeah.
Now we are changing R2 only, you see, only we are changing R2, the voltage, yeah, the resistance. That time we are getting the voltage in R2 5.3. Also R1 is changed. That is coming 2.7, right? It was 2 before, now it is 2.7. So by changing the resistance, we can change the output. Now, for example, for this context, you are getting the output across R2. But there you will get some context where you will get the output across R1. That time you have to calculate with R1. Is it clear? What
Yeah.
will be the formula for R1? If your V out is given in R1, then how you will write the formula? Can you tell me please?
R2 থেকে R1 দিয়ে দেব
Yeah, just in place of
এটা
this
top up
R2, there will be R1. That's it. Nothing is changed.
বুঝলাম না
Yeah. For example, Aisha,
হুম
here we are getting V out, right? If I change the V out, like V out is not here, V out is here in R1, then
okay
you have to calculate V out for R1, isn't it? Then will
oh
you
okay
write the formula same way or you will change it?
we'll have to change it
Yeah, how you will change?
instead of R2 like on the top
The upper
we'll
one,
write
the upper
R1 the
R2.
numerator
Yeah, just replace R2 with R1.
R1
That's it. Is it clear now?
yeah
So this way you will get some numerical questions in both MCQ and structured. That one you have to understand and apply. So we are done with potential divider, variable also, potentiometer. Now we are going to some applications of this potential divider. That's why it is electronics. If we are only thinking about potential divider, that is only DC circuit, that is only current electricity. But if we are applying it for some more complicated instruments like thermistor, LDR, then we are starting introductory electronics because it's working like switch now. the way you learned already. I talked to you about some gates, logic gates. So those logic gates are actually working like this. If one is on, another one is off. Look, if we have more temperature, then output how it is changing, we'll now understand. Look, here we have thermistor, right? Hello, hello.
Yes, sir.
Yes, sir.
So thermistor, what is the working principle of thermistor? What is the working
Heat
principle of
বাড়লে resistance কমে।
Yes, if heat increases or temperature increases, then resistance decreases. If your resistance is decreasing here, like in thermistor, resistance is decreasing, according to potential divider formula, what will happen here? If your resistance is decreasing here,
ওইদিকে resistance বেড়ে যাবে।
if resistance is decreasing here, then voltage sharing will be also
We're
less, right?
sharing also.
Decreased.
Voltage sharing will be also less. If your voltage sharing is less here, that means the output will be more here, right? In R2, isn't it? So, hello, are you understanding what I'm saying? If your
Right.
if your voltage sharing is less here, then voltage sharing will be more in R2. Do you agree? Hmm? Like here, we are giving you uh, like before 8 volt. So, if your temperature increases, then you are saying resistance decreases. So if resistance of this one decreases, ratio of resistance is more here, so voltage will be shared more here, isn't it? According to potential divider formula. Just now we did.
Yeah.
Okay. So if your voltage is here more, then we can say here output is more, isn't it? Voltage is a V out. This one is more, isn't it? So, and all these things written here. Look, when the temperature rises, the resistance of the thermistor falls, the potential difference across the thermistor becomes low. Most of the potential difference is now across R2, which turns on the electronic switch. Is it clear now? Hello? Hello?
Yes, sir.
Yeah. So you write here application of potential divider. Here write the heading application of potential divider. Then draw this diagram and write these 3 steps. Here, how the fire alarm is working. The fire alarm is one electronic device, and we are having that one using the potential divider, circuit, where we are using the thermistor.
So তারপর কি লিখবো? Application of potential
Yeah,
divider.
application of potential divider. After writing application of potential divider, you just uh, draw this circuit. After drawing this circuit, if you have place right or left, you write these 3 steps. Otherwise, you write down. Siva, are you using mobile?
Yes, sir.
So can you send this snap to our group?
Which one?
This one,
Just this.
this one, yeah.
Just the diagram and the fire alarm part.
Yeah, yes, yes. If you don't understand, tell me, I will explain again. Eh, okay. Aisha, have you understood?
Yes, sir.
Otherwise, I will give you numerical example and that formula you will apply, then you will understand more.
पहले है न्यूमरो फॉर्म में देते देखा जाना.
Should I give you?
Yes, sir.
Okay, fine. Like,
Sir लिखे.
okay, right, you're right. I am writing in the right side, no problem. Like this one has 8 volt. The way we did before, we are writing the same thing so that you can understand it easily. Now, for example, this one is fixed resistor. R2 is fixed resistor, and for this fixed resistor, uh, you have 4 ohm. Making it simpler, then this one is also normally it is at normal temperature it is 4 ohm. 4 ohm at normal temperature. Okay. 4 ohm at normal temperature. Now you calculate V out using the previous formula. I am not writing the formula, you just do it and tell me the value. For these values and this condition, you just tell me what will be the V out.
Twelve.
Hmm?
12.
How 12? You are using that formula. V out equals V in multiplied V2 R2 divided by R1 plus R2.
R1 plus R2. जी sir,
Yes.
it is.
So how it is coming? That one you are saying. Are you writing properly in the calculator? Your calculation will come this way. Your
4.
V in, yes, 4 volt. Yeah. Now you are right. 4 volt. So 4 volt, this one coming for the normal temperature, right?
Yes, sir.
If if uh, if there is fire, yeah, they are saying it's fire alarm, right? So if there is any place fire, what will happen? Will the temperature will be normal, or the temperature will increase?
It will increase.
Okay, so that one also you are writing. If the temperature increases, then what will happen? Your thermistor resistance will decrease, isn't it?
Yes,
And
sir.
for example, we are thinking it is now 2 ohms at higher temperature. We are writing at higher temperature. Okay. Now you calculate V out how much at this temperature, higher temperature, when the resistance is 2 ohms.
5.3.
5.3.
3.
5.3 volt. Okay. So we understand now that maximum potential difference is going through R2. So it is at higher temperature. Now your circuit is made in a way that if your uh, voltage across this uh, output or this R2, if it is more than 5 volt, if it is more than 5 volt, then your fire alarm will ring. Is it clear? Hello?
Yes, sir.
So that time the fire alarm starts ringing, and we are having any other system like they are saying here, the sprinkler system will work. Okay. Is it clear now? The whole statement is clear now?
Yes, sir.
Okay, you see example is making us more confident. Okay, now the potential divider rule, the one we learned, we applied it for thermistor. Yeah, now we can apply another one, that is light dependent resistor. We learn how the light dependent resistor is working. That one also we can understand the same way. That is also electronics. Okay, now you see here we have light dependent resistor. Are you seeing?
Yes, sir.
Okay, look at the diagram. Are you done with the previous one?
Yeah.
Okay, you have taken all the notes, right? At normal temperature,
Yes,
at
sir.
high temperature, everything, right? Now
Yeah.
we are having here, please take the notes. You will not get this one even in any book, this way, everything together. So if you take these notes, it is very much helpful for you to solve the worksheet, to get the through the past papers. So here we get the action of light dependent resistor using the potential divider rule. Okay, so you write here uh, action of LDR using potential divider circuit. Are you writing? Yeah,
Yeah.
yeah. Action of LDR in using potential divider circuit. Okay, so this one is our now discussion going on. Look here, we have this circuit diagram. Huh? So what is the property of LDR? Do you remember
The dark.
how if the light increases, then resistance decreases, right? Isn't it?
Yeah.
If light is less, then resistance is more.
More.
Okay. If light is less, then if the resistance is more, then you will get more output in this circuit, isn't it?
Thermistor মতন like
Yeah,
temperature কম
yeah,
হইলে resistance
it's
বেশি
it's almost similar. One is for temperature, another one is for only light. That is the
light
difference. Okay, so uh, if light is less, then more resistance here, right? Yeah. So if light is less at night and your street lamp is given across this LDR, then voltage across this part of the circuit will increase. Yeah. If voltage across, like the street lamp are designed in a way, or they are connected with the circuit in a way, so that if you are having like before the fire alarm is working, like you are crossing 5 volt in the LDR, that time this street lamp will start lighting. Is it clear now?
yeah
Okay,
can you
so
say it again
yeah, I am saying that like before we saw that if we are getting here more output, huh?
hmm.
Yeah, if we have darkness, that means light is less, isn't it, at night?
yeah
if we have
then
if we have less light, then we are having more resistance, isn't it, for
yeah
LDR? If we are having more resistance, that means we are having voltage output more across this circuit, isn't it?
more voltage
Yeah,
তাহলে
more
লাইট
voltage.
বাড়বে
Yeah, if we have more voltage, that means the light will start working. Is it clear now
হ্যাঁ
how the street
হ্যাঁ
lamp is working? So you write it here, please. Draw it, and you write the statement. I just said you, and I am also writing here that one. Then it will be more understandable to you. At night time, due to less light, resistance of LDR. These things are not that difficult, but as as you have to go carefully step by step, because it is potential divider. uh, we are sometimes messing up this one, mixing up, right? That time we are doing mistake. That's why we should be careful. That's it. The idea is not that difficult, but so many ideas are working together. That is the main thing, right? So if you want to get for your target answer, you should go with some steps. One step, another step, another step. That's why if you are not careful for a certain step, then your answer might come wrong. You need just some carefulness. That's it. The thing is not that much complicated. Due to
স্যার
less light.
প্যারালেলে ভোল্টেজ সেম না
Mhm.
প্যারালেলে ভোল্টেজ সেম না
Sorry.
প্যারালেলে ভোল্টেজ সেম না
Yeah. Parallel is voltage same. We listen. We always do potential divider in series. Okay. You will never get potential divider in parallel. But in some circuits, you will get much more complicated. Where part of the circuit you see, like here we are getting only one resistor, right? Only this LDR, but there might be another resistor here with parallel. That time also you are getting potential divider. Like this side one is one, and this side another. The RP is another one together. We'll get it in our worksheet. We'll get that type of question. Okay. Due to less light, resistance of LDR, what should be it? Increases, right?
increases
Yes, increases. Therefore, voltage across voltage share, that is more appropriate. Voltage share across, therefore share, okay, share voltage, shared voltage, you write shared, huh? Shared voltage across LDR increases. Hence, the lamp leads, or you can say, or brighter. Okay, anything you can say. Is it clear now?
Yes, sir.
So we are having another class. Our time is very close here. You see, it's 2 minutes. Some seconds are left. We are joining again after 6 to 7 minutes. Okay, because I need some
Okay.
time for this process of recording. Okay, thank you. Huh?
Okay.
Are you done with writing?
Yes, sir.
And Ziba, again, please take the snap and please send it in our group. This one with my writing also. Yeah, with my writing also. Huh? Okay, thank you. Huh? Join after 6 to 7 minutes. Okay.
Okay, sir.